Infosys provides world-class online IT training, staffing, and software testing solutions to customers worldwide. H2K Infosys, how we are different from our competitors. 100% job-oriented training, hands-on project work, cloud test lab, resume preparation and review, mock interviews, robust syllabus, one-time fee and lifetime access to classes, access to recorded sessions of live classes. H2K Infosys has won the trust of thousands of students worldwide. For a free demo class, visit us at h2kinfosys.com.
So yesterday we had discussed about the file storage and about the HDFS architecture on a very high level, right? And also we had discussed about what is name node, what is a data node, and also on a high level like what is a secondary name node and their functions. So is everyone fine with those points? Okay. So let's have a very quick 1 or 2 questions today about yesterday's sessions, because the reason why I'm having a question here is everyone should be knowing what is a name node, what is a secondary name node, like the 3 main demands of HDFS. Because without knowing that, it's very difficult to continue in the next sessions. Okay? Hadoop is a framework that allows for the distributed processing of. So that's the question. Can anyone answer it? Okay. Rahul has answered me like large amount of data. Okay. So anyone else who wants to take a shot? Okay, fine. Thank you, Rahul. So let's see the answer also now. The small data sets or the large. Okay, Akshay has answered me like unstructured data. Okay, Akshay, it's not only particular for unstructured data. We can handle structured data, unstructured data, and semi-structured data. So all types of data can be handled in Hadoop. Okay. The options you have is small data sets and large data sets, and Raghu has answered me like large data sets. So let's see what's the answer is, okay? Large data sets. The answer exactly is it is also capable to process small data sets. However, to experience the true power of Hadoop, one needs to have data in terabytes, because this is where RDBMS takes hours and fails, whereas Hadoop does it in few minutes. So it's not the matter of a large data set or small data set, but definitely Hadoop will have its beauty whenever if we give an input in large amounts of data. So that's what the answer is. So let me have one more last question. What are the demands that get started when HDFS is started? Come on, I want some other guys to answer this question. No one want to answer it? Come on, yaar. Right, Arjun. Yes, it's nodes, but we want to know like what are the actual nodes that get started whenever HDFS is active. Okay. Akshay has answered me like maybe data node. Anything else? Name node and data nodes. Name node by Arjun again. Still any more answers? Okay, so everyone is partially correct, but let's see the right answer. Okay, it's the name node, secondary name node, and data node. So all the three daemons will get started whenever I install Hadoop and HDFS is active on Hadoop. Okay, so that's what about yesterday's sessions and yesterday's topics, like how the block replacement will be there, how the blocks will be divided, and what is the typical architecture of the name node, master slave architecture for name node and data nodes, and what would be the default block size and all those things. Okay, let's start with today's session. So in this diagram we are seeing few more new terms, right? So let's come back to Hadoop architecture again. Hadoop has actually two teams, which is called as HDFS team, and which is used for storage, and the second team is called as MapReduce team. So MapReduce team is used for processing. So if you take only HDFS, the master would be the name node and the slave would be the data node. And when it comes to MapReduce, the job tracker would be the master node and the task tracker would be the slave node. So all these two components will act in master slave architecture. Okay, let me give you in this way. Masters in Hadoop architecture. One is name node and other is job tracker. Slaves will be data node and task tracker. Okay, this is what on a high level. So the job tracker is associated with name node and the task tracker is associated with data node. In the sense, the data node and task tracker will sit on a single machine and the job tracker and name node will sit on another machine, on a single machine. And don't worry about the secondary name node, you can have it as a unique node itself. So if you see our 100 cluster now again, it is modified as machine 1 is having name node and job tracker. Machine 2 is having secondary name node and machine 3 is having data node 1. Machine 4 will contain data node 2, so on to machine 100 data node n. So is it fine, guys? You all understood about how would be the typical architecture? So the machine 1 will contain the name node and job tracker, and machine 2 will contain secondary name node, and machine 3 to machine 100 will have all the data nodes. So along with the data nodes, I will have task trackers corresponding to that data node. So this is how the task tracker is distributed on each of the data nodes. So each data node will contain a unique task tracker. So that's what this diagram shows about. So the name node and job tracker is sitting on one machine which will be maintained by the admin. Those two will be called as the master nodes, and the data node and task tracker will be sitting on another machines, and those two will act together as slave nodes. So the job tracker and task tracker is associated to the MapReduce engine, and the name node and data node is associated with the HDFS cluster. So is it fine with everyone? Okay. Thank you, Arjun. So let's see on a high level what job tracker and task tracker does. So I'm not talking much about the job trackers and task trackers in HDFS sessions. We can discuss much more when we get into MapReduce topics. But on a high level, I want to introduce like what is their functionality. So whenever a client submits a job to the job tracker will take all the responsibility to process your request. So what job tracker does is, job tracker will coordinate with several task trackers to perform the actual task. So all the processing will actually task trackers only. Only the job tracker will maintain like, okay, which task tracker needs to perform which task. So it again acts like a name node only. So that's the reason it is called as master node. Okay, so it will decide which task tracker to perform which particular job. But the actual daemon which process the job is task tracker only. And if you see here, in each task tracker, I am having two words called as map and reduce. So the task tracker will perform two functions called as a map function and another is a reduce function. So don't worry about this map function and reduce function. I will discuss much more in detail when we enter into MapReduce sessions. But as of now, just remember like there will be two functions that will be running on each of the task tracker. The first function is map function and another function is reduce function. So after having all the daemons, this is how the typical Hadoop cluster looks like. So we have discussed about what a rack is about, right? A rack is nothing but a collection of machines, or I can say it like a rack is nothing but a collection of nodes. So on each of a rack, I will have different number of nodes. Suppose if you take the rack 1 here, I am having a main node in my rack 1, and along with that I have several data nodes. So as each data node is associated with the task tracker, on each of the data node I am giving as data node plus task tracker. So if you see my rack 1 here, I am totally having 5 machines. The first machine is name node and the remaining 4 machines are data nodes plus task tracker. And the same is the case with rack 2 as well. But rack 2 is containing job tracker in it. So it's okay that I can maintain name node and job tracker on the same on the same rack, or it is fine that I will maintain independently in different racks. It's up to the admin like how he is going to set this particular cluster. That's it. So, and also if you take the rack 3, you are seeing a secondary name node here and several data nodes plus task trackers. And in rack 4, if you observe, we are having a client sitting on rack 4. But when you take the real world clusters, most of the cases client will be outside the cluster. And again, it's up to the admin like he will decide whether he wants to keep the client in the cluster itself or out of the cluster. But in general, the client will be out of the cluster only. So if you see here, each rack needs to communicate with another rack. So that will happen with switches only. So the rack 1 will talk to rack 2 using the switch. So if you want to know like what exactly is a switch, it is like a modem which is used to interact. That's what I can say about switch. So the information will be passed in the form of packets from one rack to another rack, or maybe from one data node to another data node. So that's the use of having a switch. So each rack will be connected through switch, and again it will be talking to another rack using a high level switch. So now let's talk about the typical workflow of our Hadoop cluster. So till now we had seen like what are the daemons that were available and what will be active and what is the functionality of each of the daemon on a very high level. So we will see the typical workflow. So the most of the basic operations as we discussed would be the read and write operations. And if you take the HDFS cluster operations, it will be termed as WOM, which is write once and read many. Yesterday we had discussed about the operation on HDFS cluster, right? It will be write once and read many, called as WOM in general. So let's take a scenario, right? I am the project manager of a company, and our CEO is very happy for the product, for the new product that was launched in our company, and we got 15 million likes for our product on Facebook. Okay. Just to know. So this is the requirement, okay. I am the project manager of a company, and our CEO is very happy for the new product that was launched in our company. And we got 40 million likes for our product on Facebook. So our manager wants to know like how many likes were there from each of the country. So that's what the question our manager is given to our developers. So let's see how we have to start with it. So that's what the typical workflow talks about. So first thing is we have to take that file, right? The facebook.txt file will be our input. So this is our input. Okay. Okay, Rajesh, you lost the audio. Okay. Let me repeat the question. I am the project manager of a company, and our CEO is very happy for the new product that was launched in our company. And we got 40 million likes in our product for Facebook. Okay, that's what the question is. So what would be the typical input for our Hadoop cluster? So it will be just the file, input file of Facebook, right? The facebook.txt is the input for our HDFS cluster. So the first thing what we need to do is we have to load the data into our cluster. So we have to load the facebook.txt file into our cluster. So that function is called as HDFS writes. So once the loading is done, we have to analyze it, right? So in order to know like how many countries has given independently the number of likes, I have to analyze the data that was loaded into my cluster. So that process is called as analyzing process, and it will be done by MapReduce. Maybe not only MapReduce, it can be done through maybe Pig or Hive as well. So it's up to us like in which way we want to analyze the data. So after the analysis is done, the output of our data needs to be stored somewhere in the cluster, right? So the output needs to be written somewhere in order to give it to client. So I have to have another function called as HDFS write once again on my cluster. So it will store the results in the cluster. So the last one would be read the results from the cluster, which is called as HDFS reads. So everything processing, storage, everything is done. So the final output needs to be given to the client. Like, okay, this country is having this many number of likes. So that is called as HDFS reads. So this would be the typical scenario of loading the data into HDFS, processing it, and throwing the output again to the client. So let's start with each of the function. So this slide talks much about writing flights to HDFS. So the user is coming and telling to the client like, okay, I'm having a facebook.txt file which needs to be processed. Can you please do it? So the client says, okay, I'm fine. Let me consult with the name node, like how many blocks should be there, what would be the block size. So, what is the admin default size, how he configured it, and he wants to know all those things, and how many times it should be divided, and what needs to be the replication factor. So the client wants to get all the type of information from name node. So client goes and talks with name node. Now name node will say, okay, fine, I got your requirement. Write your blocks into data nodes 5 and 6 and divide your blocks as 3 number of blocks with 64 KB of default size and have the replication factor as 3. That's what the name node will say. So client is happy for the information that he is getting from the name node, and he will divide. Maybe for example, you take the input file as file.txt. So the client will divide the file.txt into 3 blocks: block A, block B, and block C. Now again, the client will go to name node and say like, okay, I have divided all the blocks. Where should I write these blocks, and how should I write these blocks again? So name node will say like, okay, write the block A to data node 1 and write the block 5 to data node, write the block B to data node 5 and write the block C to data node 6. They will say that. Okay. So then the client will actually write the data into data nodes. So he will write the first block A into data node 1, and he will see like, okay, whether it's being written properly or not. So again he will write this block A to different data nodes, because the name node has told him to write those blocks for 3 times, because he has given the replication factor as 3. So for now, just don't mind about how we are going to write the blocks or how we are going to distribute the blocks in different data nodes. There is a particular policy for that. We will discuss about that. But for now, just think like I am placing those nodes randomly. So the client will have the block A on data node 1 and maybe again on data node 7 and data node 9 block A. So once the block A is written, again he will start writing the block B. So he will write the block B on data node 5 and few other data nodes. So once the write functionality is done, the output would be like file.txt is divided into.
Hello?
Hello?
Yeah, Raji?
Yeah.
Yeah, Raji, I was trying to join this session before half an hour. And I don't know why it was not letting me to join. May I know the reason why you do, why I'm not getting this type of things?
I'm not sure. Let me check whether if it's the same case with other applications.
Is it possible where I can get whatever I paid back? Because I'm trying to sign this thing as soon as I can, and after half hour session I'm getting this. So what is the meaning?
From where you are trying to log in?
Since 1 hour I'm trying to log in into this.
No. Is it from a tab
since
or?
9 a.m. No, I'm using a laptop.
Okay, then I think you have to check with the organizer Kunal, because I think everyone have joined the session.
Call the,
I mean,
yeah,
I'm not
call
sure,
the, give
what
me
is
the number of organizer. I don't have any other option. Since 1 hour I'm trying.
Okay, no problem. We will share this video along with the recording, okay?
I mean, what is the meaning of sharing if I can't get into the, if I wanted to look at the videos, I can get the videos online also.
Yeah, I mean, probably you can very well check with Rav on this Kunal. But hopefully it
Rav
should
is not
work.
picking up the call. Rav is not, I'm so much angry right now. Rav is not picking up the call. Mr. Rav, I don't know where is he. He's not picking up the call right now. I'm getting frustrated on this time now.
Let me check with him, Kunal, because I am not the one who is operating on this. So let me check with him.
And this is ridiculous.
Hello Kunal, we are in the class. Everyone is joined the class. We don't have any problem. So call tomorrow morning and we will discuss with you, okay?
Yeah,
you have to call 770 number. And sorry to interrupt you. Please let's continue the class. Let's continue the class. Everyone is in the class. We don't want to discuss in the middle. We will share this video. If you are not comfortable, we will refund that money to you. But please let's continue this class. We will talk about this offline tomorrow. Our team will talk to you, okay?
Rao sir, I want to ask you just one thing.
Yeah, please, let's not discuss about this. I request you to not discuss about this. Let's continue the session. I understand whatever you are talking. Let's continue the session. Please call our number 770 number tomorrow after 10 a.m. Our team will talk to you, please. Let's continue the session, please.
Okay.
So, okay, let's continue the session, friends. So the file.txt is divided into 3 blocks. Okay. Block B and blocks. So after writing and after getting the instructions from main node and after writing the blocks into data node 1, the typical data node will look like data node 1 will contain block A, data node 5 is containing block B and data node 6 is on block C. Okay, but after the replication is done, maybe the block A will be stored on one, 6, 9, and the same case will happen with remaining blocks as well. Data node 5, so this is how after the replication it will look like. But as of now, trust me, don't worry about how the replication is happening and on which how we are going to decide like which block should be stored on which data node and how the replication should happen. So we have few slides on that. We will discuss about that policy. Okay, but still as of now, just imagine like the block A has been replicated on 3 data nodes, 1, 6 and 9, block B on 5, 8 and 11 and block C on 6, 12 and 23. So it's fine with all you guys about writing files to HDFS. Writing files is a bit complicated thing and it's also a very important thing. So that's what even the slides talks about. Client consults main node and client writes blocks directly to data node. And here it is the main point. Most of the people will confuse like name node is the guy who is writing to the information to data node. But that's not the case. Client is the one who will write data to data nodes. Client will just only talk with data node and get the instructions like where to write his blocks to which nodes. But client is the original guy who writes the data to data nodes. And data nodes replicates these blocks. And again, once the block A is finished, the cycle will get repeated same for block B and block C. So, but before writing this, the actual internal operation is the client is the guy who will write only to data node 1. So if you take the block A of file.txt, he will write the block A only to data node 1. And internally, data node 1 is the guy who will take and repeat the block A into another data node. So if you see this line, client is talking to data node 1 and data node will talk internally to data node 5. And again, once it's written to data node 5, data node 5 will be responsible for writing this block to another one. So the replication will happen in a step-by-step basis. Not that client will write all these data nodes, write all these blocks to different data nodes. Client will write only to one data node, one particular data node, and that particular data node is responsible for writing to different data nodes. So that's how it happens. So once it has been replicated thrice, so the data node 6 will give an acknowledgement back to client saying that, okay, data node, block A has been written to 3 data nodes and it was written successfully. So an acknowledgement will be passed to client. Then only he will start writing the block B. Or else, until and unless he doesn't get an acknowledgement, he will not start writing the block B to different data nodes. So this is what internally happens. So it's like a pipeline, right? So it's fine with everyone, guys? Any questions on this? I just want to hold on for a second. Okay, Krishna has a question. Is replication happens parallel or sequential to other nodes? It will be sequential. If you see this slide, it's like a pipeline, right? So once a block is written to data node, that data node will serve to write it to another data node. So it will be sequential, Krishna. Is it okay? Fine. Okay, let's continue. So we have one more question. Let's see. Why is client waiting for block A to finish? So suppose let's take a case. Okay, client is writing block A to different data nodes. Okay, so until and unless that particular file is not being written, maybe the client is trying to write block A to data node 1. So let's take this case. But what if data node 1 is not working properly? So until and unless this block A is not written properly and replicated thrice, what is the meaning that he goes to next part of the file? Because that particular block of file is not written properly. So there may be any case that causing the failure, right? So he has to wait that until and unless he see the actual problem and get a proper acknowledgement stating that block A has been written properly, he will not go and proceed for block B. So any question? Then I'm seeing couple of questions here. It's like clubbing everything. Try to type all your question in a single chat, okay, so that it will not be clubbed with another questions because it's getting a bit confusing. Why is client waiting for block A to finish? I think I have answered that question. The second one is after entire block is written to node 1. That's what. Before starting one, log B. Let's write. Krishna, Does my answer is fine with you, or are you looking for any other question? Raghu and Krishna, just let me know if you have any questions, okay? We will continue with the class. Sorry, Rahul and Krishna. Okay, thank you, Krishna. Okay. So this is how the acknowledgement happens, okay? In a pipeline, right, if you see here, the first one will be, the first operation will be data node 3 comes and says, okay, I am fine, I had written block A into my node and it's okay with me. So it will say to client like, okay, I got everything fine and it's a success message. So the same will be repeated from other data nodes also. So data node 2 will come and say to client like, okay, I had written my block and I'm fine. Data node 1 will come and say to client like, okay, I had written my particular block on my data node, I'm fine. Everything is okay. So client will be happy for getting all the acknowledgements, and then he will go to main node and say, okay, seems like all the data nodes have properly written their blocks respectively and I'm fine. So shall I go and continue with block B? So name node will say like, okay, if everything is fine. Yes, the arrows are going to name node as well as to client. So the acknowledgement will be sent to both of them, to the client as well as name node. So these data nodes will say to client like, okay, it is successful, and along with that, these data nodes will tell to name node like, okay, it's successful, I had written those blocks. So then if everything goes well, client will also give another acknowledgement to name node like, oh, okay, I had written my complete file with block A, block B and block C, and name node, it's fine, my functionality is done, you can close your metadata. So then name node will come and see like, okay, I'm happy, everything is well, everything is processed very well, I can close my metadata. Okay, so once all the blocks were done, name node will update it metadata like, okay, there is one file called as file.txt and it has a block A called, and it is written to data node 1, 2 and 3. So it will repeat the same with for block B and block C. Okay, block B is stored in blah 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 data nodes, block C is stored on blah 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 data nodes. So it will go and update its metadata. Okay, so fine, Rahul. Okay, so let's come to second functionality called as client reading files from HDFS. Okay, so the reading function is not much complex like the writing function, because in writing there were several acknowledgements and everything will go in a pipeline format. But the reading functionality is a bit easier. Okay, let's see. So the client is getting a requirement from the end user like, tell me the block locations of results.txt file. So the end user has given one question to client. So client has to process it. So what client will do is, my end user has instructed me to read result.txt to name node. So he will ask that question to name node. Can you please return the blocks of that particular results.txt file? He will ask the same question to name node. So as name node is having its metadata like which block has been stored in which data node and all that type of information, name node will check the results.txt file. It will go.
H2K Infosys provides world-class online IT training, staffing, and software testing solutions to customers worldwide. H2K Infosys, how we are different from our competitors. 100% job-oriented training, hands-on project work, cloud test lab, resume preparation and review, mock interviews, robust syllabus, one-time fee and lifetime access to classes, access to recorded sessions of live classes. H2K Infosys has won the trust of thousands of students worldwide. For a free demo class, visit us at h2kinfosys.com.